Hello, welcome to the video for the jam breakdown for January 2016, Zila Part 6. So, at this point, if you're still with me, I think I've covered pretty much all of the basic game. At this point in the game, I think I'm middle of Saturday, maybe a couple hours into Saturday. First of all, I actually lost all of the work I had done on Saturday at this point because I was an idiot. I was in the middle of doing source control, backing up stuff before I went out for a little bit. And I clicked the wrong button. And basically I told it to roll back everything from the previous commit. So basically all of my work disappeared. I thought it was highly ironic while I yelled and screamed at my computer that the source control, which was intended to save my stuff, actually ended up making me lose everything. But thankfully, I'd actually committed everything to my source without actually sending it to the internet. But locally, I committed it before I rolled it back. So I ended up rolling back the rollback and I got everything back. So I was happy. Everything was saved, but there was still a lot of cursing. So let's see. What did we finish up for the last day? We have a game. We have it working. We have a loop. We have a startup screen. This one's pretty simple. It's just a map. It's a startup map. This is one of the last things I did. And I don't know why, but I always leave I leave the last stuff for, I leave the first stuff for last every time. It's always funny. It's really simple. It's just a startup screen. It's got an about page, which pops up, and it's got the start thing, and then you click, and you go. I didn't want anything fancy this time. I just wanted, boom, you get right into the game. So that's it. That's all the startup screen does. It's an interface. You click a button, you can start the game, and there's an about panel. So that one should have been pretty simple. Now, let's go back to my map. Let's cover something else, which I said I was going to do. This is one small little thing I like to do as well. We have text here. Trying to put a minimalistic user interface or trying to put instructions in a way where they're not obstructive is something I try to do continually because I'm trying to give the user a little bit of an experience when they play. I want to give them a little bit of a polish. And this was the way I decided to do on this game. These are just text renders that are on the screen. As you can see, they're off there a little bit. And they just give the basics. Controls to move, mouse to look, mouse button to fire. And like I said, they pop up. They're there for 5 seconds before the game starts. It gives you a little bit of the ability to hopefully learn. And then they're gone. Now, one thing you may see different about these, and this is what I wanted to point out, and this is something I actually like and think is important. Let's go ahead and put a text render in here and bump it up. And we'll compare the two. Now, hopefully you can see the difference. We have this text renderer compared to that text renderer. And it's not a different color. These are both white. The difference is the default material that is used for text in a text renderer is going to be here. And it's going to be an opaque texture. It's going to use the vertex colors, which is white, but it's going to put it on the base color, and it's going to be a surface material domain with default lit. What I like to do is I usually duplicate this, which is actually what I did here, and then I go in and I change it from base color to emissive color. That way the color is lit up. That way, because it's emissive, it's not affected by your external lights. This is a great way to have a uniform looking color for your font. So actually I can change this to any other color I want and it's going to be uniform. And it's not going to be affected by your external lights since I'm using static lighting. And it looks cleaner and it's a great way to have it stand out. So that's something I always recommend if you're going to use a text renderer. Duplicate it, change it over to the emissive channel. You can even change the shading model to unlit. And it'll give it a little bit more of an effect as well. So that's one of those small tips I want to pull up. Let's see, what else do we have? We have our lights. Our lights are pretty simple. These are blueprints. And all I did with them, this was the first time I decided to do a jam using static lighting, which I hate build times on static lighting. And this is pretty simple. It is simply a mesh, which is a square, which is just a little cube mesh I made. And it's got a point light inside of it. And inside the mesh itself, I'm just simply using a simple material, which is a emissive color with the base color, so it's actually affected by light, with a slight bit of opacity, so you have a slight bit of transparency. If we were to actually go in and let's pull down. Oh, it's hard to see, but you can't see because there's nothing underneath it. But it's partially transparent is what it is. And let's undo those. We go back. And there we go. There's our lights. And the nice thing is that just I can drop them into here in the scene. And they react based on how far away they are from the top. They give me a nice bit of light. And it gives me that, overhead light effect. That's what I aimed for. And I just threw them all over the scene. And for here, you can see these are partially transparent, hopefully. It's the same material. I just used it on a brush. One thing I hopefully pointed out, this entire level is made out of BSP brushes. It should not be. For example, if you look in this room right here, it's solid black. But if I go back far enough, we're going to see a crack. Now, it is using a BSP brush box, and it is using hollowed out inside with walls. You should not be able to see that, but it's kind of a bug with BSP where you're going to be able to see that, and if I'd used static brushes, I wouldn't have that issue. See how you can see a little bit there too? It's annoying. I saw it, I got annoyed, and then I said, you know what? This is just a game jam game. It's going to work good enough, and it's done. So that was it. So I didn't worry too much about that. I try to color code things where red are my exits, blue are my stairs, orange are my walls. All of this stuff is just simply, this is just a solid BSP brush with a BSP cone subtractive and then some BSP brushes put on top to give a little bit of effect. And it's kind of cool because you get a little bit of shadow because it's using lighting. Okay. So that was the basic build and layout of the level. Let's see, what other blueprints have I not covered? We have the intro and we have the waves. Okay, so apparently I forgot to cover everything for the spawn manager, and that was my bad. So our spawn manager is here. I discussed how it worked, but not how I set it up. So what I did was, in our spawn manager, as I exposed 4 variables. 3 for the spawn points, which you see here are basically just references to my spawners on each of my floors. And then another one, which is waves. Waves is a wave info struct, and as you can see, it is a bunch of crap. Wave info structs are awesome. It's a great way to organize things. Is integer called num waves, float, wave delay, float, integer, vector, and float. That's all it is. It's a struct that basically holds the information for the wave. What enemies am I going to, where, when, how, what am I going to spawn? And it's pretty simple. The first one is just how many waves, the delay, monster, how many enemies I spawn, which floors I spawn on. Remember I told you floor 1, 2, and 3, and then the delay after last spawn. And it ramps up, and that's it. If I want to add a new one, I can hit new. If I want to delete or reorganize, you can delete and reorganize. And that's it. That is how my spawner works. I basically created a blueprint in the scene. And for example, if you had someone who you wanted to actually do this properly, they don't need to know any coding. They can come in, click on your spawner, adjust the waves if needed, test things out immediately, you're good to go. And the cool thing is, because it was designed to be worked on, if you go in to here, everything is, the current wave is the wave that spawns. So if I was to actually change this to 5 and hit play, we're going to go ahead and it's going to jump straight to wave 5 instead of wave 1.
Bing bong.
Technically wave
Bing
6.
Bong.
And then now we get wave 6 spawning. Because it's an array, we're going to get wave 5 spawning right here, which is what we saw. Floors 1, 2, and 3. with a bunch, 15 of them per wave on each one, 6 waves. So that was a good way of creating it where it was adjustable and editable for testing purposes, because it kind of sucked having to go through everything. So I made it where it's exposable. So I forgot about that. So that was our spawn manager and our wave info struct. Now we have a matinee game mode, which I'm going to cover in a second. And then we have our game state, which I covered in our game mode. And then game instance is nothing. I put this in there just because I might have used it and I didn't. I was going to use a high score maybe that saves, and the game instance is good for that. But I decided not to do it. Okay, for our special effects, for our I-beams, the Infinity Blade assets, which are available for free on the marketplace. There is some laser beams, and right here, I basically just took the default laser beam, adjusted it a little bit, and made it where it's short, and I learned how to use the beams. You can actually set beams to targets, and that's how when I click and I fire, it's firing from the front, and it's going to wherever my missile's target is.
Bing bong, bing bong.
And of course, if it's too far away, it
Customers
can
need
only fire straight
assistance
ahead.
on floor 1.
And I use the default beam particle emitter to do that. Let's see. We already covered our maps. We covered these are all the meshes I used in the game. 3 meshes. And this one's technically was a test destructible box. That's the entire thing besides the models I pulled in from Fuse and the model I made in Moto. It's made out of these. Technically, these were just BSP brushes I converted to meshes, and everything else is BSP. Pretty simple. Our people. Okay, so this is one of those issues I ran into that would have come in, not been an issue if I'd thought ahead of time. So I decided I wanted to end up with 4 different enemy types. So I needed to end up making an enemy character base class, which I talked about, of which all my others are subclasses of. So it gives me that function of searchability. This code I talked about should be moved into the enemy character and then appropriately adjusted. Now here's the cool thing. Because I have one, when I used Fuse, everything was built on one skeleton. It's got your basic same joints. Different sizes of people, I tried to use the basic same size, but the skeletons are the same. They're leg joints, they're arm joints. Because I used Mixamo for their animations, it goes based off the skeleton, and so they're all the same. So if you notice, under animations, I actually have people. I have running, walking, yelling, idle, and then I have a people animation blueprint, a people blend space, and a people skeleton. All of my different people, my 2 males and 2 females, are actually using a same animation blueprint, the same skeleton, and the same animations. They're just adjusted for the mesh itself. So how that works is we have our animation blueprint right here. And how our animation blueprint works is pretty simple. Basically, if it's valid, all I'm doing is getting the velocity of our character. Now, our character's velocity is gotten from our character controller since we're using the character actor. And what this is doing is converting it into a speed. That speed is then used inside of our animation graph to determine if it should be running and what speed it should be running at for the animation. This is what our blend space is for. And this is a blend space. Basically, nothing, idle, walking, and then running. And of course, you have like full speed, slower speed, so that way I can get different animations depending on, of course, it looks funny because I haven't adjusted it. But again, this was, all in all, creating the characters, downloading the animations, getting the animation blueprint set up, and my blend spaces took probably an hour for all 4 characters just to get them running and working in the game. That because I used all the default tools with Unreal Engine. So they look a little funky. Most of the work with animation is tweaking, but they worked, which is what counts. So this blend space basically tells it, based on the speed of the animation, And the graph right here is basically taking the speed that the character is running at and putting it into the blend space, and then the blend space is saying, okay, well, which animation should you use? And that's it. That's all it works. I added in something else later on, which is this part right here, which is called yelling. And that's this checkbox. And you'll notice in the beginning, oops, I should put this at 1 probably. They yell like they need help or they're looking for customer service. And all I did was basically, it's a transition. And I don't think I've covered animation yet. I'm pretty sure I haven't covered animation yet, and I'll be covering that in another video set. But basically, if I tell it they are yelling, it starts a yelling animation. If I tell it they're not yelling, it goes back to whatever it was doing, idling or running. I'm only using this during my intro. Other than that, it's never called during the actual gameplay. And that sets up. And the yelling speed is a different variable that determines the speed at their animation. So I have that way during the actual intro scene, I have slight variations on everyone's complaining. But that is our people blueprint, our people blend space, and our people skeleton, which allows the different meshes. Here, let's go with running. Here's running. Let's drag this down. So we have her running, and we have him running, and her running, all using the same skeleton, the same blend space, same animations. So that is a great example of quick time saver to get a little bit of variety in the game and using all the same base stuff. And when you import, basically you can choose the skeleton and the blend spaces and the animations, and they all come over. It's fantastic. Now you will notice, like I said earlier, I only used one destructible mesh for all of them because I didn't want to waste resources and time creating multiple destructible meshes, duplicating disk space, and honestly, it worked good enough. So, what else do we have? I know there was other things. Oh, I haven't covered the intro. I knew there was one thing left. Okay, so then we have the intro, which is our last part, which was kind of funny because the intro was literally the last thing Technically, the intro was the second to last thing. I pulled the audio in last. I guess we'll cover intro and audio. Okay, so the intro. It's this little room. What I did was I pulled up my mall map. I saved a new copy of it and named it my intro map. Then I proceeded to just simply delete everything else that I didn't want. So that way I had the same basic layout. Because if you notice this right here, where is my mall map? Is the same corner where your character starts in over here. All I did was simply delete the stuff I didn't need. So that way it looks familiar. One other change I did is I changed all of my lights. I created, if you notice, these are called square light movables. What I did with these was I changed them to movable so that way they could cast shadows. Because if they're not on movable, we are not going to get shadows cast. You're not going to get shadows. And I thought having these shadows from the people was a nice little effect. Fortunately, that gives me that really weird looking effect. See if we shut off cast shadows. They don't look as bad. And that's just one of those things because I didn't spend a lot of time working on textures. So I added shadows. We have our little button here. And I scaled him down really small just so he's there. And then we have a matinee track. Which if we open up our matinee. And let me pull this off screen. Oh, I hate when that happens. There we go. And basically all I'm doing with that is it starts off, you can see it here. And I run through the matinee. Because all my matinee is doing is controlling the sound, which you can actually probably hear, I just realized. It's controlling the sound of the camera, all based on our matinee right here. Now, matinee is getting replaced with sequencer in the future, but basically all I'm doing here is our camera movement, which is our little points we saw as we move the camera. And then I have it fade in. And then I have it play our waiting sounds. I have it play the pushing me sound, the getting upset sound, and then the last, I'll give you customer service. So that's what our matinee does. It gives us a little bit of our intro. In terms of code, we have our intro manager, which I just a little guy stuck in the corner to handle our event. I like to hard code events like this just because, I mean, they're one-offs. You might as well hard code it. And basically, I have a couple things here. I have my set timer by function, which is our make button large, which is down here, which I call after 24 seconds. Again, I hard coded it. I could have used a blueprint event if I wanted to. Then I get all of my skeletal mesh actors. These are all of my people. I go ahead and shuffle my skeletal meshes. And then I set a delay right here between 0.4 seconds and 2 seconds. Now, if I clean this code up a little bit to make it easier to understand, do it like that. Okay, so we'll do it like that. Okay. So then after my short delay, what I'm doing is I'm checking to see if it's a valid static mesh, if it has a skeletal mesh component, and then I cast it to my people and in blueprint, my animation that I'm using for animating my people. If it fails, it's right here. Right there. Here we go. If it fails, it goes ahead and it does nothing, and it tells it to go on to the next static mesh. If it's successful, it randomly picks a speed between half a second and 1.5 seconds and tells it that's the yelling speed, and then tells that mesh to yell. Now, the reason why this is here is, and this is what I figured out after about 20 minutes of debugging and getting annoyed, I figured all of these are skeletal mesh actors, all my people, right? Well, I kind of forgot. My button, he's a skeletal mesh actor. So I kept finding my button in the array, and it kept failing on trying to animate my button. So it's one of those little things I had to debug. So anyways, what we do is we go through, randomly pick a person, randomly tell them what speed they should be yelling at the button, and then we continue and go back to our loop. And then we pick a random delay, and we continue on. And that's it. Now, why did I have to do this? A delay, a random, a branch, using an index. Why couldn't I use a for each loop? For each loops do not play nicely with delays. If you're going to try to use a loop through an array and you want to have a delay involved, you kind of have to basically fake your own loop. For each loops do not work very well with delays. So I'm basically faking a for each loop here by looping through them manually. And it's basically just going to give me an effect of during
I've been waiting all day.
Where's your manager?
I need help.
Hurry up! I've been waiting
customer service. This is boring.
This is taking so long. This sucks.
Hurry up!
Ow.
It's
It's not gonna be
crowded.
the same one every time.
Stop pushing.
So that is what that does when it starts up. Now as for this is our set timer by function name, make button large. That's going to be this little thing down here. Basically after 24 seconds, we get our button. We figure out what our scale is on it. We have a multiplier, which I set up to 0.01, and then we basically make it bigger. And then we continue doing this. Where is it at? Right here. We do that every 0.1 seconds. Rather than doing it every frame, I basically have it every 10th of a second. I make it bigger. And it will continue being bigger until it gets to a certain size. That's our maximum size. Once it hits that maximum size, we go ahead and we find all of our people. We make sure they're people and not our player, our button. We go ahead and we spawn one of our destructible actors, our little exploding Gibby person, and we explode him. And then we destroy our original person. Once we've destroyed all our people in our hail of blood and guts, we go ahead and we look through our brushes to destroy. That is this one and this one, our wall. We destroy those. Once those are done, we go ahead and take our button and move him to the ground. So it gives us that effect of people complaining, button grows bigger, everyone explodes, these things get destroyed, and he goes onto the ground, kind of like, obviously you don't want him floating in midair. So that is how our animation sequence works. And then, of course, once that's all done, we have inside of our actual level blueprint, we have a finished actor node, and that basically opens up the map up for them all. So that is what our intro does. That is how our intro works. Let me see. I think that might be the basics. We've covered the intro. You go into the game. You control how your player plays, how your player fires, how your player runs around, and player kills. Oh, I forgot one more thing. So I went ahead. I remembered the other thing I have not covered yet. Let's do audio fairly quickly. So for audio, basically, I imported a bunch of sounds. I went ahead and did some recording with my kids. One of them recorded the announcer and the people. The other one recorded the main character itself. What I tried to do was use the cue, audio cue function, sound cue function for Unreal Engine to give a nice bit of variety and to fix some common issues you might run into. So for the announcer, those sounds were done basically only one at a time, and the delays were set up so they wouldn't overlap. So there's no issues there. But our lasers were something where we could get some issues. So if you use a cue, which you can get from the, I always forget sounds, the dialogue, there we go, sound cue section, you'll find something like this. Now by default, you're going to have just an output. What you can do with that is it allows you to, one function that I use it for is I had 6 different laser sounds that my son made and I edited. Using a cue, I can actually pick one of them at random and output it. So by making your sound wave player here and assigning your sound wave and then piping it into a random node, you can go ahead and output that. Now the random node's kind of cool because it's got some options here. I don't know if I've covered sound cues or not yet, but I will at some point. But as a basic overview, basically I take the sounds, pipe it through a random, and then it outputs it. Now one of the cool features, and this is something that happens, and this is one of those little things that kind of like the unlit text gives great player feedback. This is something that you will notice if it's actually not there. Having sound overlapping. With these lasers, since some of them are longer than my 5-second delay, I mean, we've got 1 second on some of these and longer. All right, let's find our lasers. Here we go. We've got 1.1 seconds, 0.6 seconds, 1.3 seconds, 7/8 of a second, 1.3 seconds. They could overlap if I was to play them back to back. In your output node, you actually have these options down here for playback. By default, you're going to find it set to this. Prevent new when you have 16 sounds already playing. So basically, it's going to limit the amount of sounds that you can play concurrently. What we can actually do is change that. We can do it to stop oldest and set it to 1. What this does is it will stop our oldest wave, which we only are playing 1, so it's going to stop the last one that was playing. And it's going to play the new one, since we have it set to concurrent play count of 1. So what this is going to do, without adding any extra nodes, this is our laser one. So if we go into our Zilla and our character and our attack, because I put it over here, we're just simply playing the sound 2D, default settings, and we're playing the laser cue. It's going to pick one of these at random, and with the way we have this set up, it's not going to it's not going to play duplicate in a row. It's going to pick one of the ones that hasn't played. And then it's going to stop anything that is currently playing and play the new one. So this will prevent overlap. You're not going to get that massive amount of just sound overload when you do it this way. Now I went ahead and did something similar for the people. Basically, people scream, pick one at random, pick a random one, and then output it. Now on this one, I didn't change any of the default settings. I kept it at prevent new with 16. If you happen to manage to kill 17 people at the same time, you'll hear 16 sounds. But for the most part, since these sounds are fairly short, they're fairly unique, and for the most part, you're not going to get a huge, massive amount of kills in the same place at the same time. You're not really going to get much overlap. So this one worked fine. Plus, I like when you hear all the different sounds, since you're using the randomizer without replacement. You're not going to get the same sound at the same time from the same place, which causes the doubling up issue. You're going to have to kill more than 5 people at a time before you get a duplicate sound at the same exact time. So it's a great way of getting randomization by only using one node. Now, I think that's going to wrap it up. I hope to heck I covered everything. I know that here's one thing I did not. Under your project, let's go to project maps and modes. You need to make sure that you have your default map set to whatever you want to start with. So for me, it's my startup map. I have my Zila game mode and my Zila game instance set up. And then for our description, basically you have a bunch of settings that are kind of nice to have set up. Any company names, any copyright notices, the project version, the name of the project, which is used when you're outputting it, project display title, which is going to be at the top of the screen when it's playing, and things like that. They're nice little touches that only take a few minutes to put in. So, I'm pretty sure that covered everything. I had one other thing, actually, if I could find it. I had a custom, this would be fun to cover as well. I have a custom preset right here called player block. And basically right here I have a custom object type. So I added an object type called player. And by default I set it to block. What I wanted to do was set it up where your player, when I find my map, let's just pull my map, pull my mall map, hit play. I wanted it where your player could not go outside the exit. But I needed to make sure the enemies could still go outside the exit.
Bing bong.
So I needed a way to have an
Customers need
invisible wall,
assistance
but that
on
could only
floor
block the player.
1.
So if we were to go here and we check out our invisible wall, we're going to find in our collision preset, it's set to player block. Player block is a custom preset I created. And all player block does is ignore everything but the player, and it blocks the player. And the player is a custom object channel called player. If we were to go into our player, character, into our collision, I have it set up where if you notice here, player is set to block. If we go into our people, and let's find one of our people, and we go to their collision settings, whoops, we are going to find it's the same thing, player is set to block. But the difference being this is set to an object type of pawn, this is set to an object type of player. So this is an object channel for responses, this is an object type. Down in here, for our object type, where is it? Here we go. I have it set to blocking the player. So by having it set up like that, what we're doing is anytime the player tries to go through this, it's going to go ahead and block the player because the player is set up as an object type of player. See, these are your defaults, and he's set up as a player. So that's how I set that up as a custom collision channel. That way the player can't get out of the zone, but everything else can. I want to say that's it. I want to say that's going to wrap up everything. There may be some things I didn't cover that you might want to know about. This is just simply a post-process volume that I set up. That if I can find in the settings. I really don't like the lens flares. So I shut off the lens flares. And I don't really like too much auto exposure. That's the eye adaptation when you're going in and out of the light. So I set that to a fixed value. By setting up a post-process volume, which I have covered before, and setting it to the unbound, that's how I was able to eliminate. Because if I went ahead and turned these, if I went ahead and just unbound it and hit play again, you're going to see the lens flares, which I don't like. And you're going to see when you come out into here,
Bing
you have the eye
bong.
adaptation
Bing bong. Customers
pretty
need
bright
assistance
from
on floor
upstairs
1.
and downstairs. So I went ahead and just set that up because I don't like it. And it's my game, and this is the way I wanted it. See? Less of an issue, no eye adaptation issue, and no lens
Bing
flare.
bong.
So, I guess I'm going to say it again. That's going to wrap it up. That's going to be the last video. There may be other things I didn't cover. There may be other things you want to see. The code is below. Everything will be up to date. I will update and comment everything to the best of my ability before the code is finalized and updated. So there may be a few different versions if you get to this point and it's not all coded and commented. If there is, there will be a note. And if you have any questions, if you have any comments, if there's anything in here you want to see covered specifically, if I get enough other questions, I'll make a 7th part of the video and explain it away.